Okay, so I'm going to continue then since I don't hear any questions. We're working on day 3, so I have just this folder opened right now. And this should be the same files that we've provided for you. You've got 3 different folders here. One's webinar, one is a save point after we set up the model control, and one is a save point after we actually exported the files. And so I do have some solutions there. We're not going to go into those solutions today. We will be covering that on Friday, probably in a post-processing session, just to give you a little bit more information on what you can do after the runs are complete. I may show just bringing them just briefly, but I will not get into any details about analysis or anything like that right now. So for this, we're just going to pull in under webinar. I'm just going to load this SMS project file. And this gets us back to where we started earlier in the day, or after yesterday, maybe. So you notice we have land cells defined up here. We have the ocean out here. One of the first things that we showed was being able to select this polygon for the activity classification. So I can right click on that and select intersecting objects, go to UGrid, choose cells, and then choose this grid. Like I said, there are a few different options here. I just use the default, and usually it's within 1 or 2 cells of the same number every time anyway. While this is selected, you can see it kind of inverted this color. It's sometimes hard to tell when it's selected or not, but you can tell the colors are different here, and you can also see at the bottom that there are 11,031 cells selected right now. This also shows you what the total area is that's selected and volume, so you might be able to use this information later when you're looking at post-processing and things like that, getting volumes for certain areas and things like that. So just to show you that this line does change through time a little bit. So as we have this selected, we can right click and we will choose to edit the cell and turn it off, and then they disappear. I'll go ahead and add in a dynamic map like we showed the other day. So I'll just choose this world imagery one. Just so that you guys can get a feel for how that's done. I don't know that we showed it, but this is what this particular grid looks like. If you want to add transparency to your grid, this probably does by default, but we'll select the U grid, and under face contours, there's an option. Yes, this is already set to show a 20% transparency. We can change that if we'd like. We can change information about how this legend shows up right here with this dialog. And another thing that we'll do probably in the post-processing, but I'll go ahead and show it now, and you can just reinforce that later by learning it again. This color ramp, by default, it comes in with a certain thing if you load a project. It may be one of these that they have added to the newer interface, or it may be a legacy hue ramp that they previously used. It's pretty much the same as these others. We do have these other options. I haven't used a lot of these, but there are plenty of options to choose from. One of the main ones I do use is this magnitude difference. When I'm looking at change from an existing condition or something like that, because that gives me a white area where there's 0 change, and then a cooler color and a warmer color depending on what I'm looking at for the other ends of that. But anyway, just to look at these, and if you need to, for whatever reason, you can flip the direction of those colors. Right? Okay, so the next thing that we chose to do was the boundary conditions. And so I'm going to turn off this background so I can actually see what I'm doing here. And one of the things that we can do is just choose to create a arc. And it doesn't have to be exact. And you can see it kind of wants to snap to the cells, and that's fine if you want to do that. I like to have it not snapped so that if I need to, I can change that later on. And so you can always, if you need to select the vertices, let me turn these on so I can see what I'm doing here. Excuse me. All right. So I already had one there, evidently. And I just created another one. So we need to delete one of these. I'm going to delete the one that was already there, the water surface elevation. I'm going to just delete that, and so I can show you how to add in information. Excuse me. As you move around, you may want to come back to a frame view. And I'm just going up here to this frame button in the interface, and so that centers everything on the screen a little bit, to the extent of everything that's actually showing. So for this case, I'm just going to select this arc. And as I said, you can either double click it or you can right click and choose Assign Boundary Conditions. It pulls up this dialog, and then you can choose, okay, what type of arc is this going to be? Is it going to be a flow rate for a river, or is it going to be some other water level based forcing? And we're going to choose water surface elevation forcing. As I mentioned earlier, there's several different options here. In this particular case, we're going to choose curve. And so I will choose, and I don't know that I kept that other file open, so let me go and extract that again. All right, and so we're going to choose this curve. We don't have any data right now. Like I said, we could enter information if we wanted to. As you need, you can change this, like I said. In our case, we're going to just import our information from this grid creation file that we have set up. And if I look at it with just Notepad, I can show you what it looks like. It's just a basic definition line that gives me 2 columns with 7,440 values and then a name. So that's how it looks like. We're going to choose this and open that up, and you can see it's replaced what was already there. We have a nice curve. We can click OK, apply anything else here that we want to. And then when we come back, it's changed from unassigned to water surface elevation forcing. Quickly, I'm going to go to the river section here and give a little bit of a demonstration of how to do forcing in this area. A couple of things that you want to make sure you do or not do in this case. So when we're doing rivers, we are providing a arc along a certain row or column. You can't have an angle with a river flow, so make sure you don't have any kind of a corner. So it's got to be either on this side or this side because of how we have the grid set up. I'll choose this side right now. In this particular case, I'm going to select that arc, and we will choose flow rate. And you see flow rate forcing, you can specify a total if it's just going to be constant into or out of the domain. This value here, if it's positive, it's always coming into the domain. If it's negative, it's going out of domain. We're going to choose a curve, and then just like we did before, we could specify some values here. And I'm just going to specify some flow rate. I'm just guessing at numbers here. So One thing you can do, so let's just do 0.6, and then I'll choose after 744 hours. So it kind of gives you a representation of what that's going to look like. Again, you can import if you have a file, you can cut and paste if you have it already in an Excel spreadsheet, whatever you'd like to do. And then once you're done, you just click OK. I'm going to click cancel so we don't create this. A few extra notes here. We have a conveyance coefficient for all flow arcs. It's usually 2/3. I don't remember any time where I've ever changed this value, and don't have a good idea of what it really does, but we do allow it to be modified if you need. But anyway, we keep it at 0.667 for the most part. You notice there is a box here for specifying the inflow direction. This allows us, okay, before I go into that, I'll just tell you pretty quickly. The flow as it comes in along this arc is always perpendicular to that arc. So it's normal to this direction. So it's coming into the domain. If for whatever reason you have a channel that's going this direction and you wanted to specify that these flows are actually coming in at that direction instead of 90 degrees to the arc, then you can actually change this and put in a value here in global space. So 0 is from the north, 90 is from the east. This is actually from the west. So this would be like 280 or so degrees, that you would want to specify for this. So anyway, that's the capability there. Just make sure that if you're not wanting to specify that and it's just coming in normal, you always leave this unchecked. Because if it is checked and you leave it at 0, then you end up with something that's not right for your particular situation. It's going to run right down this column and have some problems. So don't change that. Don't check that box unless you actually need it. Any questions before I move on? Okay. So in our case, I'm deleting that because we're not going to be using it. I'll go back out. And so the next thing that we covered was creating simulations. So we will right click and have an option to add a new simulation here. We're going to be choosing CMS-Flow. And now it says CMS-Flow simulations and has a default name of sim. If you like, you can rename this. And I think we did Short River Inlet. Test run 1 was the name or something, whatever you want to use there. And then you can actually right click on each one of these and then apply it to the simulation. I'll apply the boundary conditions, I'll apply the activity classification, and then I'll show you when you go to apply the quad tree, there's no apply for the quad tree generator because we're not applying this coverage, we're actually applying the grid. And so don't get upset that you can't add this one. You're actually wanting to add the grid itself, and there's an apply to up there. All right, and so we have all three down here and ready to go. And then we can right click and go into model control. I'll shrink this a little bit so we can see it. So as I've already gone over several of these, we changed the starting date for this particular run to January 1st, 2001. We made it 744 hours. If you wanted to run with different options here, you can actually say, I'm going to run for 92 days instead. Go back to hours, it puts that value in. So whatever you want to do, make those changes here. And we'll leave the duration as 24. We have this initial conditions file. If we're wanting to start from scratch at 0, this is always going to be considered a cold start. And so we will just write out these different hot start files. So there's one that's written out for at a single time, and then there's an automatic recurring hot start file that's written out every 0.5 hours. You have choice between solver solution schemes. We're going to leave it as implicit for this particular case. We have different options here for the matrix solver. We're going to leave that by default, and we're going to use 4 threads. I'll go to flow. By default, it always starts at 10 minutes. But you can change this to be higher or lower. I wouldn't go crazy on this number. Doesn't quite make sense to me to go all the way up to half an hour. You're just missing out on a lot of different processes that are going on. So 600 seconds is what I normally start at. There have been occasions where I've had to reduce it down to, say, 450 or something less, maybe 300 seconds. But for this particular case, we're going to run at 600 seconds with a wetting and drying depth of 0.05 meters. Coriolis, we set this display projection so it knows where we are as far as the latitude. And so it automatically assigns that. Some values here. We have a data set. I didn't create that data set. And unfortunately, this interface doesn't allow me to create it within here. So I'm actually going to have to get out and go back and create these data sets. So let's just go ahead and do that. It's under data, data set toolbox, data calculator. And this first one, I'm just going to put in a 0.025 and call it Manning's in. Let's do it to the cells. And we're going to do 0.26 millimeters for the D50. And negative 999 for the And if you see, we now have data sets up here. If we select one of these and hover over our grid, we can see at the bottom down here that these are all set to 0.025 or whatever we assigned in that data set. If we needed to change those values, we can come in and select specific cells by either a polygon or a rectangle or whatever method. You can actually choose to select these by data set value if you know what those are. And once those are selected, then you're able to change this S value. Never change the Z value unless you're wanting to change the bathymetry. But this S stands for scalar, for these scalar data sets. And so you would change this value. It would modify the value for these individual cells and then leave the rest alone. And so you'll do this on occasion. Hard bottom, you would apply this to your jetties, your bridge pilings, areas where there's large turbulence. The Manning's in would be affected in different places. So you would just set this up and use that way of changing those values as needed for your particular project. So I'll go back to model control. And now I can actually set this value. So I can go in here from Manning's in. I'll show you the other options. There's just a plain bottom friction coefficient. There's also a roughness height. And you can select the data set that goes along with it. One of the things we've talked about doing is to allow, instead of a data set, if you're never going to change these values, maybe allowing for a constant value that you can put in here, and that way you don't have to create that data set. That may be coming in future versions of SMS, but right now, all of these different ones have to be done with a data set. These turbulence parameters, we just recommend you never modify those. Those have to do with anti-viscosity and what's going on with the hydro. If you want to play around and do some things, you can turn this on and change those values, but it's not recommended for novice users, or even for me. I can't remember the last time I changed these values. So, but you do have the option if you want. I'll go into sediment transport real quick. So we have these different options. I'm going to choose to not start for the first 24 hours. I'm leaving these as they are. There are different options here for each one of these. I will note we do have a formula for C2 shore now. So we get some cross-shore applications, but you see a note here saying you've got to have wave forcing as well to be able to use this. It's red because it knows that you don't have a wave grid and you haven't specified that. So there's some parameters here. For this particular case, we're just going to use LUNSERP. In the past, we've used LUNSERP, Van Ryn, and Soulsby Van Ryn, and gotten relatively decent answers with these three. We've started running some with Seashore. I think this initial formulation is based on the LUNSERP, so it has a lot of the same properties, but it also has the cross-shore as well. Sediment density, sediment porosity, you can change those if you like. Just scrolling down here, I don't know why I changed that. You can change the D50 for this base layer. So we're going to choose D50. And you notice you have several different options here for these percentile data sets. If you have more than one layer and you want to run with that, I'll add one here. The top layer is always an automatic calculation for the thickness, but the other ones you have to tell it, get the thickness from a data set, or just let me specify a constant thickness, whatever. So just have that in mind if you are running with more than one data set or bed layer. There's some scaling factors we didn't really talk about earlier. There's a bed load scaling factor and a suspended load that just governs how fast the sediment is moving in either the suspended part or the bed load part. Typically, this is areas that we're trying to validate and compare with existing results. We'll change these values a little to try to get better representation or a better match with what's going on. There's this morphology acceleration factor that's used when you want to accelerate the sediment transport. Say you're running for a week, but you really want to simulate a month. You can actually make this 4, and then I'll change it to 4 times the total movement of that sediment. Typically, we just start with 1, and if you absolutely need it, you can increase it at your own risk. We do have somebody this summer and fall that are looking into sensitivity and possible changes to this, but right now, this is what we've got. Excuse me. So I mentioned the transport grain sizes earlier, so you can add in the different grain sizes. In this particular case, we're going to be running with 0.26. But if you needed more, if you wanted to also run with 0.3, you could do that. Typically, you may have some sediment samples that you've done in your area, and you know what some of the main grain sizes that are being carried around in your area are, so you might want to add those here. I mentioned avalanching before, and the hard bottom. I'll go ahead and turn that on and assign that hard bottom data set. And then you can move on to the other tabs. We're not going over water salinity or temperature. Wave we'll get into tomorrow, but you have the capability of choosing to force the CMS flow grid with pre-run waves, which you can specify here, or if you want to do it interactively where they're passing information back and forth, you can do the inline steering. You just have to tell it where the wave file is, how often to do it, and then a couple of other options down here, but we'll get into this tomorrow. Wind, we have a spatially constant, but temporally varying. So it's a curve that you can specify right here. So you can give it, cut and paste the time, directions, and velocities of that wind. And that will use a constant variation of that over the entire grid through time. So every cell will get the exact same value on at each time that's specified. If you have multiple gauges that you want to use, then you can have choose this meteorological stations, and you can add any number of these. You have to basically tell it where it is in space, X and Y. That would be here. What the height of those gauges are, give it a name if you want, and then you can edit the curve, and this is exactly the same as the previous. But that would be duplicated for every one of the wind stations that you might need. And then you might have a file that defines all this information for your run. And that would be any one of these types. We have Navy Fleet, Fleet Numeric. We have OWI, PBL. That's kind of a ocean weather hurricane type wind. Or you can have a single ASCII, and then there's different values and different setups that you would have for each one of these, defining those. So for our case here, we're going to just turn this off and then go to output again. We can change the name of this, and I'll just call this run 1. We want to change this to be 744 hours because that's the length of our run. You don't necessarily have to go the entire time, or you can actually turn this off and not have any output during that ramp time as well. So whatever you'd like to do here, you're able to. You can have multiple lines here. So if you know, okay, I want hourly increment for the entire time, but during this one period that I have a storm, it might be between hour 28 and 40. You want half hourly output, you can do that, and it'll create this, and it will have times at half hourly during this window and then go back to hourly for the rest. Something not that we don't typically do, but we can if it is needed for the user. And then you assign different lists to the different options that you have here. You want to turn on morphology change, make sure you do that. If you want to see transport rates, you can turn that one on. By default, a few are already selected, but others can be added as they're needed. All right, and same thing with waves, wind, and eddy viscosity. All of these are available for output. You can output some statistics. We're not going to get into that, but it kind of helps when you're doing the validation. You can look at a few different things for the hydro, the sediment, and for salinity, those 3 different types. Then we have a few other options down here for how do you want the output to show up. Do you want it in ASCII? Do you want it in binary? Typically, we always get it in binary because these files can be pretty large. The problem is that when we move this over to a Linux environment or HPC, they don't have the binary XMDF libraries, and so everything has to be ASCII output. So we have that option, and if you need that, you can turn it on, and that's about it. So we can just click OK. As I said, I would normally save the project and then save the simulation. And so I'll go into this folder just so you can see what is happening over here as I do this export. All right, and so when we save the simulation, hopefully I've set everything up correctly. See, it runs the model checks. It says multiple sediment size classes can only be defined if there are multiple bed layers. So when I was going through that option, I had added an extra one and I didn't go back and change it. So let me go change that real quick. So sediment transport, come down here. I'll delete the second diameter. If you have one, then you can get by with one bed layer. If you have more than one, you have to have more than one bed layer. All right, we'll save again and we will export or save the simulation. It goes through and runs those checks again. Hopefully it won't find anything new. You see over here now, it gives you, so there is some kind of an error there, but it creates a new folder called models in that same folder that you're in. And so under that, you see models, CMS Flow. So everything that shows up in here relates to your simulations. So we have a CMS Flow simulation, and there it is. If you had any AdCirc simulations, you'd have an AdCirc folder. If you had any GenCade simulations, you'd have a GenCade folder. So they all kind of show up the same way now. In our case, we only have CMS Flow right now. And so if we go in, we see the name of this is SRI Test Run 1, and that's actually the name of our simulation. So if we had 3 alternatives for these simulations for CMS Flow, we'd have inside the CMS Flow folder, we'd have 3 simulation folders with different names. Once we get in here, we see the necessary cards for whatever we have assigned and defined inside of this. When we are actually saving that simulation, it pulls whatever we need into this folder, or it adds the special cards to the file to let us know exactly where they need to go. So that's kind of what it looks like. And at this point, if I wanted to run, I think there's another problem. Let's see, model control. I think I have something still related to wind in here. Because when I opened that file, it said something about meteorological stations. So I just want to delete that so that I can get a clean run for you guys. So I will click OK, and I will resave that simulation. This box that comes up basically shows some information as it's writing it out. I stopped it automatically closing. There is something going on here. I don't exactly know what, but I'll have to figure what that is. I don't think it affected anything because we still wound up with files, and everything now looks fine to me. So I'm going to just close the screen, and now it can try to run it. And so when we run CMS, you don't give it a file location for CMS by default. It automatically it knows where the CMS files are stored. So you can check that under Edit Preferences. There is a File Locations, and why they can't alphabetize this, I don't know. But CMS Flow is down here. I've got it set to a specific location. Normally, it's going to have some file location underneath Program Files, SMS 13.3, similar to what it shows here for AdCirc. So when you actually run yours for the first time, that's what it's going to show. I've reset it to use a specific version that I want to use for my case. So if you had that, if you're running a version of CMS and the one that comes with SMS by default is not working, and you want to try an update from one of us, you can tell it exactly where you place that file so it will run that in the future. So in my case, I'm just going to right click and choose Run. And fingers crossed, hopefully everything will run fine here. It's off the screen, but this is what the output looks like. So it shows that it's running. It's still at 0 hours right now. I've already calculated an hour and a half. Here's 2 hours. It's going through. I don't know that anything's actually running here. Not getting any changes in water surface elevation. So I must have done something wrong, but this shows you, hey, you've got to choose and you got to find out what's going on for your particular case. So I'm just going to stop this and remove it. And then I can go back in and actually run one of these other cases that I got together for you guys for these different save points. I was really playing around in the interface showing you guys, so I'm just going to actually come in and choose to bring in this particular case. Excuse me. And then I can try that again. And so I'll go in, I'll resave the simulation. And run, and hopefully we'll actually see some decent results here. All right, so here we go. We're actually seeing some values here, so we know it's running and it's being forced. Otherwise, it would have stayed at 0 like you saw earlier. And you can get an idea of how fast this is going and get some kind of an estimate of how long it's going to take. Periodically through this window, we do print a statement that says elapsed time and expected completion time. It's like every 30 or 40 iterations, maybe. It'll print that out and give you some idea of how long it's going to take. And I mentioned that residual plot, so it's still early, it's still calculating this. And so it's still building that up. Any other questions before I move on to just a new topic for the waves?
Yeah, this is Mark Damon, I'm Center More Engineers. I just had a quick question regarding calibration. In the past, we had used the acceleration factor to calibrate a model, but I was just curious to see what you would recommend using.
So you're talking about the morphology acceleration factor?
Yes.
So that would not be my first go-to as far as changing for validation or anything like that. What I would prefer you to change, excuse me, is the scaling factors for suspended in bed load. So these are the first things that we change. So we would change these to like 0.7 or 0.6 if we're getting too much bed load movement or too much suspended movement. These are the ones we normally change for validation efforts. We only really use this morphology acceleration factor for our research right now. We ran a case where we wanted to see if we could run 100 years and what that would do. So we basically ended up getting forcing for 10 years. And then we made this acceleration factor 10 and then did some comparisons. At some point in the future, we might be able to use this morphology acceleration factor a little bit differently. But I would stay away from this if possible and try to tune the model a little bit better for validation with these first two parameters.
Yeah, that acceleration factor is mostly used for long term, like Mitch said, it's 100 year. For short term simulation, don't use that one. Yeah.
I think I saw Michael raise his hand first. So you have a question, Michael?
Yes, thank you. In locations where there are substantial influences of regional currents, and we have and we need to also specify a water level boundary condition. Is there any way you could have both the water level or the tide and then at the same time have velocities in your boundaries?
So the only way right now that we have to be able to do that is when we are forcing a CMS grid with some kind of a parent, whether it be a CMS Flow larger parent or a AdCirc grid. In those cases, those water levels and velocities were already computed for the larger solution. And so when we choose the parent, I will just quickly go in and show that particular screen so you can see. So I choose, say, parent AdCirc. We get the water levels by default. We can turn on to use velocity, and then we can force it with the velocity file too. I think the same thing is there for CMS. You're only specifying what the card file is, and it gets both the water surface and velocities at one time, and you don't have to make a choice for that particular one. So I think that's what you're talking about as far as forcing. I don't know of any other way without a parent to use velocities to force. Does that make any sense?
Yes, okay. Thank you very much.
Okay. And Mohammed, did you have a question?
I just wanted to follow up on the MORPHAC use or the suspended bed load factors, in the sense that all of them are linear multipliers. The two for the suspended and bed load may require some understanding of how we can relate the suspended load to the bed load, and which it might seem arbitrary if we try to reach calibration with one is 0.6 and one is 1.2 versus the MORPHAC, which is a multiplier or a factor for the morphology itself. So
Right.
when fine tuning, you could use it in that sense. Like if you put the morphology change at a 0.9, you're basically calibrating with the outcome versus trying to arbitrarily put factors to things that need to be need to have a reason, unless you're using the same. So if we use 0.9 in the MORPHAC or 0.9 in both of the suspended and bed load, that theoretically should give us the same answer. But I'm just trying to understand in the formulation, is any of those factors is not linear? Because if it's linear, it doesn't really matter.
Yeah, I don't know the answer to that question right off the top of my head. Maybe Hong Hai can answer that. But I think that the suspended and the bottom scaling factors, or the bed layer scaling factors, are applied before the sediment is actually moved in the model. And that morphology acceleration factor just takes whatever was moved for that time period and then multiplies it by that factor. So I think there is some is done actually changing the way the sediment is moved in different ways with those first two factors. And then, as you said, that morphology acceleration factor is just a multiplier. And so it takes whatever was moved and increases or decreases it by that amount. I think that's how it is done. Like I said, we have somebody really looking into that morphology acceleration factor this fall, and hopefully by the spring we'll have a much better understanding of exactly how it's implemented and when the better times are to use that. Okay, Bruce, do you have a question?
Yeah, when you were talking about the flow forcing for the river boundary condition, your flow coming in perpendicular to the grid was not in the direction of the basic river channel. So
Right.
Would you put the flow in perpendicular to the grid and let the model sort itself out? or would you use that direction correction to try to get it sort of started in the right direction?
Right. So what you sometimes end up with, let me just draw an arc here, and I'll try to turn on some bathymetry. I don't know how well this particular case at this point is defined bathymetry wise, but let me just look at this real quick. Yeah, so it's not really well defined right here. But say,
I mean, if you assume it's like a normal river channel, you know, it looks like it's, you know, coming down from north-northwest. Assume the bottom of your channel's in the middle. Oh.
So one of the things that we've run into is that the flow is coming in not in the middle of this arc, but at every one of these cells. And if there is a cell that you're specifying for it to come in at, and the next cell or really quickly thereafter, it runs into land or whatever, then it's going to have some problems. It's going to have to immediately change course, and there's going to be some instabilities. And the reason we put that angle in there is maybe then once we force by coming in at an angle, then we can better avoid those areas. It may just be a matter of, hey, we shouldn't be forcing that cell anyway. Perhaps we need to just change,
Right.
you know, where we're importing or we're pulling in that flux from the outside to which cells. Sometimes people just choose to only do it in the deepest part of the channel, and that's fine. We typically try to do the deepest part plus a little bit of the outside, and then internal to CMS, we look at the depths and we redistribute the flow so that the flow goes down the deeper parts of the channel. So I think that kind of answered your question why we want to do the angle sometimes, is just to avoid those instabilities of coming in and immediately having to change direction. If it's wide open, it shouldn't be a problem, but so there may be some cases where you need that.
So it's just a matter of if you get instabilities, play around with it.
Yeah, that's what my recommendation is.
Yeah. Okay.
I typically, when we implement this, I always look at what that angle of the normal channel is, and I just always put it in there.
Okay.
Just to avoid problems from the get-go. But you know, it shouldn't be an issue as long as you're not immediately coming in and hitting a land cell or whatever. And that just goes into how these external boundaries are defined. You need to be, you know, a little bit careful in how you design it, so you don't have an immediate water cell then right next to it as a super land cell or whatever.
Yeah.
So, you know, you just, right.
Yes. When I apply the river boundary, and we often see this kind of issue. If the boundary sit on the land cell, the model will cause the model instability. And usually the user have to manually open up some cell to have water there. And then you allow some water flow in, and then the model getting stable. Yeah.
One thing I will say, and if you look at this particular way it's set up, the way I drew this angle right here, let me get rid of that one. Okay, so this, what I'm showing here is the activity classification. So right now, this arc says that anything inside of here is water, anything outside of here is land. You would not be putting your flux boundary way out here. So what we would do is this really, if we were going to be forcing a river, we would change this a little bit. Something similar to what I'm going to show here, to where we have cells that are all in a line, and I'm just doing this so I get more than half of the cell is going to be outside of the computation. So I would put the boundary condition in this particular case here. And so what we can do, and I mentioned this earlier, is you can right click and choose to do the generate snap preview, and it should come back and tell me, hey, these are the cells that are going to be forced with this river forcing arc. And then you can look at the bathymetry and see what's going to happen here. Does that make sense? It doesn't.
Yep.
Your river or your boundaries don't always have to be on the external side of your grid. In the case of river flow, you can have it inside an internal boundary, but it just has to be at a wet-dry interface.
Okay, thanks.
And Michael, you had your hand up for a minute, but you took it down. Is there anything you need to ask?
Yes, I'm just going back to the bed load, suspended load, suspended sediment load, and then also the morphology acceleration factor. Is it possible to have a spatially variable factor? And can we even have a temporally varying factor?
Not at present. This is the only implementation we have, and yeah, we haven't thought about using these scaling factors in that kind of a way. It might be something we can look into implementing, if not temporarily, but maybe spatially being able to vary it. We have talked about these bed slope diffusion coefficients and the bed slope friction coefficient here, being able to do more of a distribution with a data set instead of a single choice. But so far, those have not been implemented. And so right now it's one value, and that's what it uses for every cell for every time.
Okay, thank you.
But we can look into doing that. We'll talk about that internally.